So next week is our public holidays. So are we going to meeting online next Wednesday? Yeah. Do you want to celebrate the Vesak Day with me? No, don't want. Next Wednesday is our public holiday, right? Yeah. So what you all plan to do evening? City walk? No idea, right? So are we going to meeting online? Yes. So okay, yeah, so we're going to have a class again. So we're going to have an online class next Wednesday. Are you okay? Or you have a plan already? Want to travel around the world or wherever you are at? No, it's possible, right? So I hope you all can enjoy the daytime and the nighttime when you come back here, come back to your home, then you can online meeting me. So okay, so now we go to our lecture 10. So as we aware, right, lecture means this is our lecture 10 on panel cointegration. So today we're going to touch on these three cointegration tests. So which are Tetronic, and also the combined individual tests. Then the next week we're going to touch on the panel area. So panel area we also can apply the asymmetric panel area as well. So that's the thing we're going to discuss online next week. Then after that is our online quiz. Right. Week 13. Next week week 11. Then week 12, week 4. Yeah, so now it's week 10. Yes, we're going to touch on this panel cointegration test. Then the panel area we're going to discuss in week 11. Then week 12 we're going to discuss on the issue. Right, correct. We're going to discuss on the issue of this panel analysis, and then week 13 is our online quiz. Yeah. So online quiz is scheduled on 5th of June. So the go anyway, 5th of June. Then week 14 going to our revision. These are the plan for the remaining 4 weeks. So now come back to our lecture text. So panel area have a similar idea like the area we discussed for time series. But there's not panel area we're going to touch on this grouping groups. Grouping groups we propose by the product. So before that, let's touch on this Tetronic and also combined. So like the time series analysis as well. So because of this spurious regression, I1 issue, when the panel data series actually is the integrated order ones, then you apply the approach that do not account for these I1 variables, I1 series, then will tend to correct the spurious regression. Means that your result going to be misleading or biased. So that's why we need to use the panel cointegration to handle the I1 variables. So now, here are the three cointegration tests for us to handle the I1 series. So for means that in our panel analysis, we will do the analysis. I will start with the discrete steady state. So we will describe our steady state like display the mean, median, some maximum, minimum for our series. Then after that, we will also complement the result with the correlation. I can see the correlation between the two variables or partial correlation. Then we will also going to conduct like the unit test, like what we did in the before our lab test. So for example, like what unit test we discussed previously, like Hartley test, and then IQS. We also got introduced you the Brinkle, for example. So and also the some panel unit test to check whether the series actually I1 or I0. So once we confirm that the series actually is I1 or I0, then we will proceed to the cointegration. So for example, if the series I0, then we straight away just apply the normal panel estimation. For example, like the phase effect, random effect, and to distinguish between the phase effect, random effect to check for it, and also the pool OS. With the series I0, if the series is I1, actually, if the series are I1, because we're going to deal with the multiple regression, right? Multiple regression not only have one dependent and also got the multiple independent variables. So you have a potential that your variable actually I1 series, right? For example, I1 for dependent as well as independent. So in that scenario, the put OS as well as the fixed effect random effect, the result may be spurious. That's why we have to introduce you the panel, like the conjugation test, just like the time series. So once you confirm that it's I1, so we have to use the conjugation test to deal with these I1 variables. So let's say the series actually is a mixture of I1, I0, because multiple regression, right? Your dependent variable I1 and some kind of independent variable is I0, and how are you going to do that? So if there is a scenario, we cannot apply this, what we say, the Petroni, Gauss, or combine into the test. In that scenario, because of this mixture I1, I0, so we will propose you to use the test, for example, like the panel ARDL. So that's we're going to discuss next week. So now, let's come back here for these three tests we're going to discuss. So before we do the hands-on, right? So what is this, right? What is Petroni, what is Gauss, and what is how they combine into the test of the work. So because of this, for this recent literature, right, I focus on the test of conjugation. Because of this I1 result, we have to search for the long run as well as the short run result for this conjugation. And the EUs provide us the similar conjugation test, which include the Petroni, which proposed by Petroni in 1999 and 2004, Gauss in 1999, and also the Fisher type test using the Johansson methodology, which proposed by Mandala and Wu, 1999. So these are the three, something like the conventional panel conjugation test that used to check whether there is a long-run relationship between the variables of interest in a panel setting. So what's the difference between among these three? So Petroni and Gauss actually based on Engel-Granger two-step conjugation test. So this Engel-Granger we discussed when we talk on this time series conjugation. Actually, Petroni and Gauss actually based on this Engel-Granger two-step framework. And the Fisher is the combined Johansson test, like the two statistics, like the trace and also the McLaren values, right? That is come under this Johansson. There's a Fisher test. So let's see one by one. For this Petroni conjugation test, so before we talk about the panel setting, right? Actually, what is the Engel-Granger conjugation test? So in 1987, right? So they're using based on the estimate of the residual of the spurious regression using the I1 variables. So if the variable actually conjugated, then the residual should be I0. So means that for these I1 variables, if the variable are conjugated, then the residuals for that particular regression should be I0. So how about if the variable actually not conjugated? If the variable are no conjugation in the long run, then the residual will be I1. So what it means? It means that if there's a no long run relationship, then the residual will be I1. Means not stationary, right? Means not stationary. There's an Engel-Granger ideas, like Engel-Granger ideas. If no conjugation, residual I1. So how about the Petroni and Gauss work? So this Petroni and Gauss extend this Engel-Granger just using the panel data. So that because the Engel and Granger is a time series conjugation test. So Petroni and Gauss extend the Engel-Granger framework to the panel data setting. So this Petroni proposed 11 tests. So even though it's just called Petroni conjugation test, but this after the Petroni got the 11 test statistics. Got 11 test statistics for our variables. So they will eventually in the hands-on you will see there are 11 test statistics for the conjugation, which allow the heterogeneous intercept and also trade correlation across the identifiers across the unit, cross section unit. For example, like if you apply firms, right? Like the 10 firms we're going to discuss. So across the 10 firms, so they allow each firms have their own intercept and also the trend coefficient. So it's called heterogeneous intercept and also the trend coefficient. So let's consider this equation, the following equation. So y again is independent variables and x is x1, x2 up to xn refers to independent variables. And this alpha actually refers to the intercept and delta refers to the coefficient for the time trend. Okay. So these two is depends on you, whether you want to test whether there is a correlation with the trend or correlation with the intercept or both. That's why here you can see may be set to 0 if desired. So if you want to test whether they are correlated in the long run with the time trend, so you can test for it. So normally we will test whether there is a correlation with the intercept or correlation with the trend. And the E here, means that this E for this static IT is referred, means that it's actually I refer to the firms, right? Firms or the country or the individual series. So T is referred to the time. This is a panel setting, right? Epsilon IT. So this E actually is represent the residual, the deviation for the long run. Okay. So what is the hypothesis? What is the hypothesis we're going to test? No correlation. So the hypothesis for all the tests is no correlation. So it means that if the test statistic is not significant, if your test statistic not significant, so you're going to fail to reject, right? Fail to reject. So your residual actually, I1, no correlation. So this is the noun. No correlation means the residual of your regression I1. No correlation. So back to the here, no correlated, so the residual will be I1. So this is another meaning. What is by no correlation? These residual are not stationary. I1. So now, so how the test work, right? So the approach is regress your equation number 1. You just regress your equation number 1 here. So you have your dependent, your independent variables. Then after that, you obtain the residual because it's based on the Engel framework, right? So obtain the residual and then regress on the residual t minus 1 together with their equation 2 residual. This refers to the equation 2 residual. This is called auxiliary regression. So what it means by auxiliary regression is a temporary, right? It's just a test equation, test regression or equation. So if you want to accommodate the what we say the zero correlation, right? So you can plug in this the lag for the changes. I mean the lag means that the lag for the changes for the residual. So as additional variables, so just like the equation number 3. So there are three auxiliary regression. So for each cross section. Okay. So what is the alternative? Because the first noun is no correlation. How about the alternative? Still remember there are 11, how you say the 11 statistics, right? So 11 statistics. Yeah. So here, so there are the different first noun, same first noun, same noun hypothesis, but different alternatives. So there are two different alternative hypotheses. Means the first one. The first one is the homogeneous alternative. Homogeneous means same means that they are co-integrated, but the rule means that is less than 1. Is a homogeneous. Homogeneous rule is less than 1. So less than 1 means they are correlation. So to be not correlated, this is not right. Yeah, this one is means that they are not stationary. So this one fully explained by the residual IT minus 1. So the rule is 1 as a null hypothesis means that the residual is I1, the residual are I1 and no correlation. If the rule less than 1 and homogeneous, that's refer to the first alternative hypothesis. So homogeneous and then rule less than 1 for the patronic, that's called Wheehin dimension test. Wheehin. Later on, we will see the difference between Wheehin rule is actually same and less than 1 for your cross section. So this is called within dimension. Then how about another version? It's a heterogeneous alternative. Heterogeneous alternative means that the row I less than 1. So this is called between dimension or we call that group statistic. So there are two different alternatives. One is homogeneous alternative less than 1, and another one is heterogeneous alternative row less than 1. So the first category is within. So there are just now we said we have totally 11, right? 11. So here the first four, I mean the first category of four statistics is within, and then the three, one is between. So actually 4 plus 3 equals to 7, right? Equal to 7, right? So let's see here. It's equal to 7. So this one, 1, 2, 3, 4. So this 4 is within. Means that homogeneous alternative, right? And then this 3 is between. So heterogeneous less than 1. And we have another 4 statistic. It's actually so weighted statistic. Weighted. So this 8, actually total 8, right, is under the within dimension, and 3 is under between dimension. So actually they are same, just that this one means that this one treat the row is actually equals across the cross section, and this one is a different row across the cross section. This one is called between, and this one called within. So and then actually all these 11 statistics is under the hadronic correlation test. Hadronic. So now let's come back here. So the first 4, right? The first 4, like the within one, the homogeneous alternative within, consists of this variance ratio, non-parametric, and also the this one non-parametric twist variance test statistic, and also diffuser. Then the second category one is between one, is based on the group mean approach. So this is just something like describe the ways the test statistic about. So now actually how this works, this statistic, this is a statistic from the equation 2 or 3. So this is the equation 2 and 3, right? So this is a statistic, and the mu, and then this v here is the adjustment term. So okay, now see how this works. For example, this one I screenshot from this paper 2015. So how this works? So not only Fisher, so we group, right? Group 1, group 2, group 3, group 4, and also together with the how many statistics here? It did not report all the 11, 2, 3, 4, 5, 6, 7. We just collected the 7 statistics. To report the 7 statistics only. These are the something like how the researcher report the result for the group 1, group 2, group 3, and group 4. So perhaps you can see a look the paper here. Let's see. Next time. Let me check this paper already. Yeah, this one, right? Yeah, this is how this researcher report the panel configuration test. And then you can see how the researcher also use the test to test for the grandeur, the panel grandeur as well. So let's go back here later. So how we can use the e-views to help us to check whether our data analysis got the panel configuration or not. So we're going to report the 11 statistics, right? Yeah, 11 statistics. So you can see you may use the various options, for example, like the train, the lattice selection, and also the spectra. Because we invoke like the Phillips parallel, right? Because we see the first 4 statistics, not only even though it's based on the Angel Granger framework, but it's still based on this non-parametric approach as well, like proposed by the Phillips parallel. And so we need to choose this, so we say the spectra estimation method. So here, you need to go to the, for example, let's just open the Garfield part 2. Here, this one, right? You open the Garfield part 2. Yeah, this one. So it seems like after our lecture, I think you know how to input the data, right? How to input the data inside. Sometimes we put without the question mark. This is a panel approach. We have two approaches, right? To input data inside the reviews. One is based on the balance panel approach. The other one is based on the pool, right? Pool as an object. So this one is a panel approach. So you input inside. So once you open, right? For example, this one how we import data inside. You go to the file, new work file, right? File, new work file, and then here you choose the balance panel. Then start that, and also the number of cross section. So for example, I have 10, then I put 10 here, right? So come up with this, then you check. You have to double check. You have the first cross section, and then second, and also up to 10. There are totally 10 cross section. Okay, because sometimes once you do the balance panel, then you forget to put in the cross section. You will not come out with the panel setting, right? Then the analysis is totally different. So that's the thing. Then another approach is using the tool, right? Then you have to put in the question mark to differentiate the identifier to tell the reviews you are dealing with the panel approach. So there's a difference. So now let's open this work file. Then you click on the three variables, which are the investment, CAP, and also VAL. These are the three variables, investment equation, right? So now we want to estimate whether the investment and the CAP and also VAL are these three variables co-integrated in the long run. So you open them as a you can open it as a group, right? As a group, then you just go to the view. Then you can go to the, for example, before analysis, you can do some correlation check, right? Do some correlation check. For example, like go to the correlation here, and then also can see whether the correlation is significant or not significant. Then you click OK, right? Then you can see the correlation between the investment and CAP is 0.66595, is significant at 1%. You also can see the correlation between the investment and VAL, 0.85, right? Is significant at 1% as well. Then the correlation between CAP and VAL is significant at 1%. So this is just like a discrete statistic for you to complement your analysis before you do your something like the formal analysis, right? So you describe the statistic with a correlation. What actually there is no issue for you going to have a very high multi-connectivity. Why? Because multi-connectivity is not an issue in the panel analysis. So there is but not too high, like near to 0.9 is something very strong, right? So there is the reason why people want to proceed to panel analysis, right? To get rid of this multi-connectivity when we deal with the time series analysis. You also can do some describe statistic to describe your data. For example, if you have a balanced sample, so there is no difference between the common and individual. If you have a balanced sample, because even though it's individual, it means individual refer to the individual series. So 200 right observation. If let's say this CAP you have a 190 only, then investment you have 200, then the individual sample will give you the different result as compared to the common sample. Because individual is report individually. You cannot see any difference here because I have a balanced panel. So for example, if I go to common sample, also common sample will just straight away take the balanced one. Individual will report, even though it's unbalanced, they will report according to your individual series. So now I want to test for the correlation, right? So you can go to view and then go to the correlation test here. So once you go to correlation test, you can see there are three different. So we're going to this, actually we applying now is a panel correlation test, which proposed by the shut down. Never mind. Open back, right? Why is shut down my files? go to view and then go to perturbation test. If I click on the pattern perturbation, then you can see the test type here. The test type here, once you scroll down, we can have three different type of tests we're going to discuss today. The patronic and gout actually based on the angel and granger approach. So that's the first one, patronic. Then for this deterministic component, intersect and trig, or no intersect, no trig. So these are the test equation. Test equation. These are the three different test equations in the patronic auxiliary equation. So for example, if I do not want to include, I want to test whether there is a perturbation with no trig and no intersect. So I will click on this one. Then, so variance calculations, normally I will not check for it because it's a correct political of freedom and you calculate the variance. Then for the mat length, because it's based on angel granger base, right? So the automatic selection. So again, it's given me the very short sample size, so I will choose the SIC. So you can figure out what's the difference between the modified SIC and also the SIC already. So now, is it now can work already? Right. So it means that your e-view solution not working. Maybe you try to run again. For example, let me see. I can okay first. Yeah. So this is my result.